So I'm going to give you a section which is circular section. In this circle, I know the circular section, what is its symmetry axis, and that I keep it as my reference axis. So this is my x-axis and this is my y-axis if it is only a circle, right? And also the centroidal axis for the circle. But now in this we have a slot made, a triangle which is removed. So keeping this AB is the vertical diameter of the circle. There is this slot. This point is C, and if it is connected here, you know that this triangle having a base as diameter and C is vertex of the triangle on a circumference, it will always form a right angle triangle. We have done this geometry in school. So now this is removed portion. So what is now left is this shaded area. This shaded area. So now for this shaded area, you have to find out its centroid. Is the centroid the same now? So when it was only circle, this point was centroid, but now this portion is removed. So the centroid would be changed. So what is the centroid you have to locate? And for this composite area, you have your centroidal axis. Find out about the centroidal axis, its second moment of area. So that is the question. So what is the question? The question is this: find the moment of inertia. Find the moment of inertia. You will have similar problem in your CAT examination, right? Not the same geometry, but you would have to work out what I'm going to work out today. Find the moment of inertia about the horizontal and vertical centroidal axis. Vertical centroidal axis of the shaded area given in this here, of the shaded section given. Shaded section given. Right? So this is the question. So how do you solve this problem? Can anyone give the way to solve this problem? What are the steps that you have to follow? I've given you the necessary theory, formulas, understanding all. You know how to apply parallel axis theorem, all you know. You know what do you mean by first moment of area. So how do you go about solving this problem? So look at here, it is asked for centroidal axis, horizontal and vertical centroidal axis. So horizontal and vertical centroidal axis are going to be this x and y for a circle, but since this triangle, right angle triangle is removed, you would have now your centroid is different for this shaded area. About that centroid, you would have your horizontal and vertical centroidal axis. About that, you should find out your second moment of area. Right? So if you are given simply moment of inertia, that means it's second moment of area or area moment of inertia. Right? So any doubt in problems statement? Any doubt in problem statement? I just want some responses. Any doubt, Aravind?
No, sir.
No, sir.
No. Okay. So you understood no means you understood the problem statement, or what does that no refer to? My question was, do you have any doubt in this problem statement? You say no. That means you understood the problem statement, right? Okay. So let us just proceed solving this. So first I have to get my centroid. So first step one is to locate xg and yg axis. So how do I do so? I have to find out my x bar and y bar. So how do I find my x bar and y bar? I have to take first moment about this axis set. So let me just describe my first area is this circle area, and second area is this subtracted area. So my x bar would be a1 x1 minus a2 x2 by a1 minus a2, right? So that is that coming from first moment principle. So what is my first moment definition? It is x bar into area is what is summation of ai xi. So that is first moment about qy, first moment about y axis. So this is my y axis. So if I apply that, so the dimension for this also is required, right? The radius of the circle, you take it as 100 units, 100 centimeter, 100 mm, you can take. So 100 mm, let us take. That's what is this. And the dimension here is given by this orientation of this side AC to the vertical. So that is 30 degrees. Right? So this is all the given dimensions. So now I can just fill in this. What is my A1 is circle area. So circle area is going to be pi r square, pi into 100 square into what is my x1? What is my x1? What is my x1? Arvind, what is x1 value here? Refer to. Priyansh. If you do not respond, I would stop at this point of time. I will not continue my lecture. Arvind E is present. Priyansh Pandey is present.
Yes, sir, I'm present.
So, what is the question that I asked? What is the value of x1 here? So, look at first section, circle. With respect to y-axis, I would have to get my x1. So, centroid of the circle with respect to y-axis, where is it located? It is the same point. So, what is x1? That is 0. You follow this?
Oh, yes, sir, because it's at the origin itself. Okay.
Yeah. So, see, there are two areas. So, we were doing it in this way, right? In a table. So, when you have your circle, just we put that two areas so that you would be able to find your. So, one is the circle, and this is referred with respect to this x-axis and y-axis. Since it is happens to be your centroidal axis, here x1, y1 equals 0. You should know, right? With respect to this axis, they are 0. If I have my axis set where I have it circled in my first quadrant, then you'd say that is R. But in this case, I refer my circle itself with respect to this axis set. So first moment about centroidal axis is 0. So x1, y1 is 0 is what is this point. So what is my second area here? So this minus, next one is this is my y-axis. I have my with respect to that this triangle, this 30 degrees, and of course this is with respect to this circle that goes around, right? So this is my second area. So for this, what is my x2, y2? How do I locate? I require to locate with respect to its centroidal axis. So this is my y-axis, and I have it here. My centroidal axis along this height, 1/3 of the height. So somewhere here is what is going to be my yg2 axis for the second one. What is my xg2 axis? So I have it here. This is my reference given xy. So from here, where is it located on this? How do I get?
B by 3, sir.
So for that, I should, when I have to calculate that, I should consider these two triangles into two more triangles. One is this triangle, two right angle triangle. One is this, another one is this, like that. This line, whatever is drawn. So for this triangle, I have to get one. So here it is 2, it is written, right? So at that time, it will become 2 more coordinates. So the centroid of this with respect to x-axis and centroid of this portion with respect to x-axis, that you have to write. So you'll understand that once I just plug in these values here for x bar and y bar when I calculate. In case you do not understand, again I'll explain. So now calculating this x bar, A1 is the area of first section, that is this circle section. This is my 1. So that is pi r square, pi into 100 squared into x1 is 0 minus what is A2? A2 is the area of this triangle. This is my A2. So area of the triangle is half into B. B is what is base here is AB. So AB is 200 diameter into H. So this is height. So this height, how do I get? What is my height of this triangle? So that we can do it with the simple geometrical calculation, trigonometric calculation. So I have now base is given 200 and this angle is 30 degrees. So what is my CD? So CD is what I needed, right? That's height. So CD is what is height of this triangle, and that would be obtained by 200. How do I get C? 200, since it is right angle, 200 cos 30 if I do, I'll get AC. At that I will project on that is sin 30. So it is 200 cos 30 into 200 cos 30 gives me what? CA. So this distance, this is CA. And CA sin 30 is what is CD. So sin 30. Is that clear? So that's going to be 86.6 mm. So height is this. So that is what I'm going to take it here. So I use the same color so that you would understand the calculation of that height. So here x2 is what is this? So this is what is h. This is what is h. So x2 will be 1/3 of this, right? Because x2 is what is this distance, yg axis distance. This is x2. So 1/3 of this height. So that's going to be 86.6 by 3. And so this numerator now, whatever is going to give me is what is first moment summation and divided by the composite area. So composite area is circle area minus triangle area. So that is pi into 100 square minus half into 200 into 86.6. So if I work out this, I would get my x bar. So what is x bar value? Simply 11 mm. You can just work out this. This is 11 mm. So this distance now, by getting x bar, what is that I get? Now my centroidal yg axis. So if this is my given composite area, and I know now this radius is 100, so I'll have my yg axis somewhere here. This is my yg axis. This is my yg axis now, because I just calculated this distance is what is x bar given by 11 mm. Any doubt? Priyansh Pandey?
No doubt, sir.
Okay. Now let us find out similarly y bar. So see, you would be able to get y bar. Again, A1, Y1. See now, see A1, Y1, it's referring to circle. So when I take this, let me once again put for this this diagram, second diagram, so that to avoid confusion, right? So this is that circle. In that circle, I have this triangle, and this triangle is what I am dividing into two more triangles. So let me take one as circle, 2 as this triangle, 3 as this bottom triangle, and I have my reference now given by this. So this is my y-axis and this is my x-axis, right? See, look at now, how do I look at the same triangle area as instead of one triangle area which is sufficient to calculate x bar, whereas I have to consider here that right angle triangle again to be splitted into two triangles. So one is this triangle, two right angle triangle. So what is that triangle? A triangle, according to the naming that they have given, this is BCD. So I have triangle 2 is BCD. That is my second triangle. What is my triangle 3? Is CDA or ACD. Triangle ACD. Triangle ACD. So these two triangles additionally I consider. So if that I consider both of them to be subtracted from circle. So this is A1 Y1, A2 Y2 minus A3 Y3 divided by total area A1 minus A2 minus A3. So it's simple now, plugging the values and calculating. So now how do you do that? I need a help. I'll ask now. You tell me what are y1, y2, y3 values, right? So area is of course straightforward. So 1 refer to the circle. So it is pi into 100 square, pi r squared. What is y1? Look at here. Y1 is 0. 0. Now A2. So A2 is this upper triangle. So what is that area? Half into B is now how much? B is now how much? I have to calculate that as well, right? So in this triangle, I have to calculate now dB. So what is my dB? Look at this triangle geometry. What is dB? dB is AB minus AD, right? AB minus AD. So what is AD, by the way? Do you know the value of AD? AB is 200. AD is to be found out. So AD is AC cos 30. AC cos 30. So what is AC now? AC, that is AB cos 30. So it's very interesting. 200 minus 200 cos 30 into cos 30. See, whatever you learned, your trigonometric formulas all are very important, right? So this is going to be calculated as 50 if you work out, right? And what is AD now? So I can calculate what is AD, because for the next triangle I require this base. So this is BD. AD would be 200 minus 50. So that's 150 mm. So have these dimensions, and now you can work out with this. So half into A2. So A2 is this triangle, half into base there is 50 into height is already calculated 86.6 into Y2. So can anyone say what is Y2? What is Y2, Priyansh Pandey?
So it will be 1/3 of the height of the second triangle.
Excellent. It is 1/3 of height of the triangle. So the same for the other also, right? Because the height is common for both. So this distance is what is my Y2 as well as Y3. So that is 1/3 from the base, that is this diameter. So that would be here 86.6 by 3, right? And the third one A3. So A3 is half into 150 into 86.6 into 86.6 by 3. Is it clear? Whatever is written on the numerator? Any doubt? See, y3 you have to calculate. I'm sorry, y3 you have to calculate, right? Priyans, see what you have told is what is x2 and x3. Priyans, you understand? Whatever you have told, that is for that. Already we have used that in calculating x bar. But y is vertical distances. So see, this is what would happen. So this already we have used it. So what is it now for y? That has to be measured with reference to this x-axis. With respect to x-axis. Right. So let me just correct that. These two values are to be properly put. So can you just find out now what is y2 and y3 with respect to x-axis. So with respect to x, you see 1/3 from CD is what is your y2. yg2 is where it will be. Yg2 is with reference to the base of this triangle, that is yg2 axis. So how much distance this should be from this? This is already 50. So 50 by 3 plus this distance, because you are finding that from this axis. So that is my y2. So y2 would be so AD is 150, where A to this point center O is 100 radius. So this is 50 plus 50 by 3. So you should write here 50 plus 50 by 3 square. Clear? So y2 is what is 50 plus 50 by 3 square. Not square, it's product, right? It's simply y2. So it's simply y2. So this is not required. So this is y2. Any doubt in this? I just have put it with the same color, what is depicted in the diagram, so that you can understand it clearly. And now what is my y3? If you are very clever, I should get the answer from you. What is y3? Priyans, what is y3?
Sir, it should be the same, right?
No, y2 is for this triangle. What is the second triangle? BCD. So in this triangle, y2 with respect to x is what we have measured, x 50 plus 50 by 3. Now take a triangle ACD.
50 minus.
ACD, what is your base? Base is CD.
Yes, sir.
So 1/3 from there. 1/3
minus
of AD. 1/3 of AD. What is AD? What is AD? 150. So this x-axis itself is, so this is xg2 axis. This is not a yg2, xg2 axis. This x-axis itself is xg3 axis as well. xg3 axis as well for this triangle. Clear? So that is going to be 0. Because it coincides. So if CD is the base, AD is the height. So when I have to measure its central axis location with respect to base CD, that would be 1/3 of this height AD. So height is 150, AD is 150. So 1/3 is 50. So when I come that, I realize that the circle, the reference axis x-axis or xg3 axis of this triangle ACD is coinciding. So when it coincides, then y3 is 0. y3 is 0. See, that is why it is 0 here. So now this is correctly filled, and then you just calculate your composite area, that is pi into 100 square minus half into 50 into 86.6. 86.6. minus half into 150 into 86.6. So this should give me value of y bar. So what is value of y bar? If you are working out, see, you have to have your calculator, you should sit and work out. You do not do this all, you will never get an opportunity throughout your engineering to do this. And likewise in the examination as well, right? So please work out at home, take the calculator, solve this long calculations, and then feel that experience. So I get here the numerator, I get a negative value, and hence I get y bar as minus 6.343 mm. So when I have minus sign, what does that refer to? It is now to be located in my composite section below x-axis. Below x-axis. So I would have my yg axis somewhere here. This is my yg axis. Yg or xg axis. Horizontal centroidal axis. So this is the centroid now. So look at now the centroid when it was originally a circle, center of the circle is now shifted to this point in third quadrant with respect to xy. So this is my centroid. So what is my centroid location now? That is x bar comma y bar, and that is equal to x bar value we got 11 mm and y bar value we have got now minus 6.343. So this is my centroid now. That's located. So now what is the question asked here is about this xg yg axis, find out your second moment of area. That is the question asked. So now we are going into for next part. So such a long problem will not be asked for 10 marks in the examination. That would be conveniently able to solve in a given time, like that section will be given. But I chosen this problem deliberately because this is a nice problem that involves to recollect your mathematics, your trigonometric relations. And one such problem, if you have understood clearly, I'm sure that you would be able to solve any given other problems, right? Okay. So now the second part of our question, we are able to locate now horizontal and vertical central axis of the given composite section, shaded area. And now I'm going to calculate the second moment of area about that section. So how do I do so that we have parallel axis theorem for that to help. So let me just write down the formula of Ixg. So Ixg is now what is the new axis that we have found about that for the composite area. So that would be, we have how many areas with respect to horizontal axis to say 3 areas. With respect to horizontal reference to have 3 areas. One is circle, 2 is this triangle CBD, and another triangle is ADC. So 3 areas. So I would have out of that 1 to be the main and then 2 to be subtracted. So let me put that as Ixg1 plus A1 into dy1 square. So understand this formula, minus Ixg2 plus A2 dy2 square minus Ixg3 plus A3 dy3 square. So what is this d subscript y3 is the third area, that is the triangle ACD. In that triangle, what is my centroidal axis? And that and xg axis parallel distance. That is the meaning of this dy3. So this is what I have to substitute. This is that now formula I have to substitute the values. When I substitute, you do not follow any of that. You please ask me. So Ixg1. Ixg1 is what? This is for circle. So let me just write down here. This is for circle. And this one is for triangle BCD. And this is for triangle ACD, right? Okay, so these two triangles are right angle triangles. So now let me substitute for the circle. It is pi r power 4 by 4. Just now we have seen. So pi into 100 or 4 by 4 is what is about central axis. But I needed about my xg about this axis, right? About what is that axis? Our xg axis. So let me just put that inside that figure. So this is a circle. This is the diameter, and I have this removed one. So this is our composite area, right? For this composite area, your central axis now shifted now like this, not with respect to the center, rather now I have it here. It's below and here. So this is my xg axis, this is my yg axis. So now with respect to this axis, I am calculating this. So when I write the xg1 axis, what is the xg1 axis? Is xg axis itself for the circle. See, xg1 axis is for a circle. So for a circle, it was with respect to this center. So this is xg1 axis. One axis, and this vertical line is what is yg1 axis, right? So with respect to xg1 for a circle is with respect to center of the circle pi r power 4 by 4. Now what is that I find out is about xg axis. Xg axis is here. So this parallel distance is what is dy1. So the distance between xg1 and xg is what is dy1, right? So I would now able to fill this. So this area of the circle again, once again, pi into 100 square is the area of the circle. dy1 is this distance. So that distance is what we have calculated as minus 6.343. So substitute that here. 6.343 square. So minus square is minus square plus. So minus value I put up. I just take this distance here. It would be clear. So is that clear here? What is dy1? So dy1 is the distance between xg1 axis and xg axis. What is that? We just calculated is 6.343, and that I have taken. So that is first second moment of area about of the circle about xg axis now. Now for a triangle. So the triangle here is this is the triangle, right? So this is point A, this is point B, this is point C, and if you project this is point D. So now look at the BCD triangle. BCD triangle, at D I have a right angle. And what is my xg2 axis? Xg2 axis is what see here in this diagram as well we have drawn. Xg2 axis is this. This is xg2 axis. So this y2 here is referred from here, but now the distance should be from the central axis. So let me just draw that axis here. That axis is here. This is that axis. This is xg2 axis, and this distance is what is from here is what is dy2, right? So now I can plug in the values here. So that's going to be ixg2. ixg2 is what about its central axis. That would be bh cube by 36. Remember this formula, we have derived this formula for the triangle. bh cube by 36 is what is about xg axis. About yg axis, b cube h by 36, right? So bh cube by 36 is the formula that you should remember, and you should put that here. So that's going to be b. Here is the CD value. So CD value was, what was the CD value? What was the CD value we got? 86.6, height of the triangle, right? So 86.6 into that is B, and what is now height is BD. BD is what is height. So BD value here is 50. So 50 cube by 36 plus A2. So A2 is half into 86.6 into 50. And importantly, now dy2. So what is dy2 is this. So dy2, you see, how do you get dy2? From this point to this. So let me just write down here with the same color so that you would know that. So dy2 is 73. That is 73. So how that is 73, you should understand. How that is 73? How that is 73? See, whereas this is located, IXG axis is located from the world reference 50 plus 50 by 3, right? Because AD is 150. So that's 50 plus 50 by 3 is what is still XG1. From XG1, this distance is 6.431. So let me just write dy2 is 50 plus 50 by 3, then minus of minus 6.4343. So this minus minus become plus. So this value is 73. That value is 73, right? So this is how you get your dy2. So that is substituted here. And this should be what in square term, right? It should be square. So that is your circle BCD. Similarly, I have to now write my moment of inertia for the circle ACD. So IXG3, ACD circle is triangle ACD. ACD is here. So its IXG3 is base is 86.6 into height is 150 cube by 36. You see here it's 50 and here it's 150 because in this triangle CACD, AD is what is height, CD is what is base. So this plus area is half into 86.6 into 150 and Y3 dy3. So dy3 value, how do you get it? dy3 value. dy3. So dy3 value you get simply it is measured from here. See this xg1 axis, whatever that is there, that is same for xg3 also. xg3 also. That's what we have seen in the previous discussion. So that is be 0 minus of 6.343. That I will get simply 6.343 mm. So I would get that 6.343 square. So that is also, these all brackets should be calculated, and I have calculated values with me. I'll just put down them. You can verify. 7984032.321.22. That is first for a circle. Then minus triangle BCD, second moment of area. So that is 1186910 minus third triangle ACD, that is 8387619.33. So this all work out to be IXG equals 595803092.
So there should be a minus sign before the last bracket.
Which bracket? Last one. Yeah, of course. See, this is minus minus and this and yeah, here there is a minus sign. That's why here it's minus. Right. So this is what you calculate now IXG value. So similarly, you can work out now IYG. IYG will have only two terms because I do not require the triangle to be splitted, right? So let us just do that quickly and stop today's class. So let me draw once again the diagram for clarity to calculate IYG. So this is the circle, and in that we have this triangle removed. So when it is removed, this location of centroid, right? Earlier it is referred by this. This is my x and y, and happens to be xg1, yg1, right? And for the circle. Now my centroid is shifted because of this triangle removed, and the CG is located now in the third quadrant. So this is my xg. YG without subscript numbers, if I put, that is for the composite area. So this is my centroid now. So this is now shifted down by 6.343 mm, and this is shifted to the left by 11 mm. And you got your new centroidal axis at this. Now I have only two geometries. One is this circle, another one is this entire triangle. So this triangle I consider to be one triangle, A, B, C triangle. So only triangle ABC is sufficient while calculating for this. So let me just write down now this formula. IYG is what is going to be IYG1 plus A1 into D subscript X. Look at now. Instead of y, I put this. Why? Because I have to go distance measured along horizontal line. Because the lines are axis are vertical axis in this case. So dx square minus IXG2 plus A2 TX2 dx1 here dx2 square. By the way, first we'll write what is this dx1 dx2 value. This is all just measuring carefully, that's all. So dx1 would be what is that yg axis, the distance between yg axis and yg1 axis, that is dx1. So this distance is what is dx1. So how much is that? 11 mm, right? What is dx2? So dx2 means I require yg2 axis. So yg2 axis, where is it located? Yg2 axis. Yg2 axis is the centroidal axis for this triangle ACB. So that would be located parallel to this. And this distance is what we know. This distance is what we know. That is 86.6 by 3. 1/3 of this height, right? If this is D, 1/3 of CD is what is from this, it is there. But now what is that you require is this distance. So this distance is what is distance between YG2 and YG axis is what is. So this distance is what is DX2. That you have to get. So how do you get that? 86.6 by 3 minus 11, right? That is your this 86.6 by 3, 86.6 by 3 minus 11 is what is going to give me this. Right, so how do I get this 86.6 from here? It is already minus this side. This side it's minus, right? Because it is measured, this is my origin, so from here it is minus value. Minus of this. So it is minus 86.6 by 3 minus 11. Minus 86.6 by 3 minus 11. So that's going to be what does that I get is minus 39.87, minus 39.87 mm. So this is the distance between YG axis and this. That's very clear. See, from here it is 86.6 minus 11. 86.6 by 3 minus 11 is what is this, right? So I can just take like that. I'll take, I'm not bothered about this sign. So minus of minus, this become plus. So this is the answer. Plus 39.87 mm. So just can you check that? Or I can write that is x2 minus x bar. x2 minus x bar. So x2 is with respect to this 86.6 by 3 minus of minus 39.87. Is that coming correct? Let me just check that. .6 by 3. I require on this side. So this distance calculated, there is, it is modulus of x1 minus x bar. So how do you get this? Is modulus of x1 minus x bar, and here it is x2 minus x bar. So this value is modulus of x2 minus x bar. So x2 is from this y-axis minus 86.6 minus of x bar. So x bar, what is that we got? X bar value 11 mm. 11 mm we got it on the other side. Minus 11 mm we could have got, right? Yeah. See here, when we are calculating, this term is 0, this is minus, so this is minus 11. Just correct that. So it's minus 11. That is why you had on this side towards left from this reference. So you have this minus 11. So when I have to calculate this distance, it is modulus of x2 minus x bar. So x2 is now minus 86.6, minus of minus, that's become plus. So this is that answer, this modulus. So what is that value I get? That's what I have to put. So that is 86.6 divided by 3. That's 28.86. So it is 17.87. It's not 39. Please correct that. So that is 17.87. 17.87 mm. So now I can fill in this. So this is going to be IYG1. IYG1 is again circle. So that is 5 into 100 power 4 by 4 plus area A1 pi into 100 square into dx1. dx1 is, so here it is x1 is what? x1 is 11 minus 11 minus 0. Right? 0 x1 is for the circle, x1 for the circle is 0 minus of minus 11, so it is 11. So that's correct. So here it is 11 square. So that is for the circle. So minus this bracket ixg2. So ixg2 would be for the triangle about ixg2 axis. is IYG2. I'm sorry, IYG2. That would be B H cube by 36. So B here is 200. 200 into B is this base AB completely. H is 86.6. BH cube by 36. Is that clear at this point? So that is this plus area of the triangle half into base 200 into H 86.6 into now dx2. So dx2 is 17.87 square. So this is that value. So if I work out this value, I would get the first one is 8,234,113.45. Second value, I made a mistake in my calculation, but that's now to be correct. 17.87 if I put, that would be changing. So I leave it to you to work out this and get your final answer of IYG. So I stop at this point. So this much mm/4. So you see that the second moment of area is always going to be positive. So this is what is that requirement. See the moment, it's only two standard geometries, but see that so carefully you have to look at them and do it. So if you are able to do this carefully, understanding why do you take this distance like this, all parallel distance, you are very comfortable with applying parallax theorem, and that would be highly appreciated if you understand this all, right? So in case you do not get, please go through video again and solve this problem yourself without compromising, understanding how these distances all are explained to you. If you understood that, then I'm sure that you can solve any problem of this kind, right? So last class we did a relatively simple problem of T section, but you see now you have like this, it's changing. So but in examination in your CAT 2 you have a limited time of 1 hour, 3 questions to answer. Of course you should be clear with your fundamentals and your solving problem skills. You should have solved some additional problems, then it is easier to manage the time in the examination, right? But all are very small, solvable. 20 minutes comfortably you can solve one question. So you have 3 questions in your examination. One is from frames and another question is from friction. Third question is from this section properties, where you will have combination of finding centroidal axis as well as finding this. So you would have similar problem, not of the same section, right? I have taken a very detailed problem for the class, but it will be relatively easier in your examination, right? So with that note, let me stop today's class, and you have any doubts you can ask, otherwise we will end the class now. I download the attendance. And stop recording.